going to be considering the general principles of naming organic compounds. And as I said, these principles are principles that are not like, they are not peculiar to a particular homologous series. If you apply these principles, you can practically be able to name any organic compounds. Now, I might make some additions to this particular study as we go further, because there are some twists when you're naming things like your spirocarbons or spiroorganic compounds or your nitrogen-based organic compound. There are just little twists to it, but we'll talk about that as we go further. Now, this particular study is going to be segmented into 4 parts. Are you there?
Yes.
Good. The first part is understanding the different functional groups. And after we are done with understanding the different functional groups, we'll get to understand the parts of an organic IUPAC name. Then we get into understanding order of priority, and then finally talk about the rules for naming. So these are basically the 4 major parts we are going to be discussing. So let's get into it. Now, first of all, is a functional group is a part of an organic compound that characterizes the compound and classifies it into a particular homologous series. Can you put this down?
Yes.
So this is not your regular definition in most cases, but this is a definition that would help you understand what a functional group does. So it is simply the part of an organic compound that characterizes a compound and classifies it into a particular homologous series. Now, the thing about this, you are writing, Abi?
I don't get the definition.
It's on the screen, can't you see it? A functional group is the part of...
No, I cannot see it.
You can't see it?
Okay, I can see it.
A functional group is a part of an organic compound. This is supposed to be organic, not organic. It's a typo. It's supposed to be organic. Yeah, that should be that. Okay, so it's a part of an organic compound that characterizes the compound and classifies it into a particular homologous series. Are you done writing so I can continue?
No.
Okay, so put that down. Okay.
Okay.
Good. So, generally speaking, they could be bonds. That is to say, in a case where you have alkanes, the functional group is single bond hydrocarbon. If it's alkenes, it's double bond. If it's alkynes, it's triple bond. There could be group of elements or atoms. For instance, when you talk about alcohols, the functional group of alcohols is what we refer to as the hydroxyl group. Are you still with me?
Yes.
Good.
Yes.
So let's take it now. So for alkanes are characterized by the functional group known as single bond. Once you consider a single bond hydrocarbon, what you are looking at is basically an alkane. I take it again. One of the things that you can use to characterize an alkane is that alkanes are single bond hydrocarbons. Single bond hydrocarbons. So you could just start writing anyway. You get, so alkanes, single bond hydrocarbons, which means if I draw this compound, for instance, C, and then you have H3, and then you have H, and then you have H. If you look at this compound, what homologous series, what family of organic compound is this likely going to be found in?
Alkane.
Why is it an alkane?
It contains only single bonds.
Is this clear? I hope it's making sense to you. Good. So that's that basically.
Yeah.
Alkenes, on the other hand, have double bonds. So when you consider double bond hydrocarbon, you are looking at an alkene. So if you look at the screen, you notice that in the case of alkene, notice this double bond. Once there is a double bond between carbon atoms and it is a hydrocarbon, it's an alkene. I did not make mention of what a hydrocarbon is, but you can take note of it. Hydrocarbons are organic compounds that contain only carbon and hydrogen. Hydrocarbons are organic compounds that contain only carbon and hydrogen. Have you written that?
Yeah.
Okay, very good. So, if you consider alcohol, is alcohol a hydrocarbon? See alcohol. You can see alcohol here. Look at the structure. Alcohol. Can you see it?
Yes.
Is it a hydrocarbon?
No.
Exactly. Why is it not a hydrocarbon?
It does not contain hydrogen and carbon only.
Exactly. So when you consider hydrocarbons, you are looking at compounds that possess only carbon and hydrogen. Okay, moving ahead. Let's continue. Now, having said this, the very next, alkynes. Alkynes, triple bond hydrocarbon. Alkynes, triple bond hydrocarbon. So you have your alkanes, your alkenes, your alkynes. This is supposed to be homologous series. Let me see if I will get a more correct picture. I said alkenes, double bond, alkynes, triple bond hydrocarbon. So you can put that down. Alkynes, triple bond hydrocarbon. Now, the next one we're going to go to is alcohol. Alcohol. Have you written that down?
No.
Okay, so put that down. Alcohol. The functional group, which is what you will see in an alcohol to know that it's an alcohol, is what we refer to as the hydroxyl group. The hydroxyl group. So if, for instance, you have a situation where I write a compound CH3OH and I ask you, is this an alkane, alkanol, or alkene? What's your answer?
Alcohol.
Why is it an alkanol? Because it has the functional group of the
Because of
hydroxyl.
OH.
Exactly. So put that down. For alkanols, the hydroxyl group is its functional group. So functional group of alcohols is hydroxyl group. Functional group of alcohol is the hydroxyl group. Should we continue?
Yeah.
Okay. Now we have the ether. When you think about the ether is basically a structure where oxygen is the functional group, not hydroxyl. This time around, what is the functional group? Oxygen. And this oxygen is attached to two alkyl groups on both sides. So you have a situation, for instance, where you have CH3O CH3. This is what we refer to as methoxymethane. Do you understand what I just said?
Yes.
You join the two of them, then this is methane. I'll still get to naming. We'll get to understand these numberings and stuff. But for now, just know that this is an ether. Once you see oxygen joining two alkyl groups, you have oxygen at the center and alkyl groups on both sides. Basically, the structure represents an ether. So you could write that for ethers, the functional group for ethers is oxygen. Okay, can we continue? Right? Can I continue? Yes, I'm listening.
The other R has something like a comma on it.
Thank
Doesn't
you.
that mean that is a different alkyl group?
What it simply means is it's possible that your ether could be represented, the prime there is simply trying to say that if you have CH3, you can have oxygen, and instead of having CH3, you can have C2H5. The point is, it can be the same thing.
But that means you can also have CH3.
Exactly. So arrow attached to oxygen attached to arrow prime simply means an alkyl group is going to be here and another alkyl group, which can be the same thing or different. Do you understand? That's why they put the prime. Is this clear?
Yeah.
Okay, very good. So let's continue. So that's that about ethers. We go to the next one. Now, the next one, as I said, the next one we're going to look at is the aldehydes. Now, aldehydes and ketones have similar functional group. Aldehydes and ketones have similar functional group, but I'll tell you the difference. Aldehydes and ketones have similar functional group, but there's a slight difference between them. The functional group of both aldehydes and ketone is what we refer to as
terminal.
Yeah, thank you. That's it. So, but the functional group is referred to as carbonyl group. What did I say is the functional group?
Carbonyl group.
Good. The carbonyl group is where carbon forms a double bond to oxygen. Then it can be attached to two different things here. Remember that carbon can only form 4 bonds. So if it's more than 4, it can form 2 here, meaning that it will remain 2. 2 other things will attach to hydrogen, to carbon I meant to say. Now, what now differentiates the aldehyde from the ketone is that in the case of the aldehyde has what we refer to as terminal carbonyl. Terminal carbonyl. That is to say that this carbonyl group in the case of the aldehyde occurs at the end or terminally. For instance, while ketones would have non-terminal carbonyl. What were we talking about? So I was trying to explain the difference between your regular the ketones and the aldehydes, and I said that the major difference between the two is that in the case of your ketones it is non-terminal, but once you are dealing with your aldehydes it is terminal. So I was trying to show you an example. So an example of what I mean to buttress this point is, imagine you have this is not supposed to happen, sorry, my board is acting up. So imagine you have so as I was saying, imagine you have something like, let's say CH3 C double bond O CH3, and you have CH3 C CH3, that's CH2. Let's just make it the same number of carbon atoms so we would see it clearly. And then here CH H, then here is H. So notice A and B, the two of them both have carbonyl groups, right?
Yes.
Exactly, two of them have carbonyl groups, but the difference between the two of them now is one of them is terminal, the other one is non-terminal. So which one do you think is an aldehyde? Which one is a ketone? Remember, aldehyde is terminal carbonyl, ketone is non-terminal carbonyl. So which one do you think? Terminal. Which one is non-terminal?
The first one is a ketone. The second one is an aldehyde.
So if you notice why the first one is a ketone is because this C double bond O is occurring non-terminally. When you say terminal, you mean the last carbon, the end. While in this case, this one is terminal because it is basically the last carbon here. I hope this is clear. Another thing you used to know is that a terminal carbon usually has hydrogen attached to it. That's a terminal carbonyl usually has hydrogen attached to it. So if I want to represent this thing using your condensed structure, you have something like CH3, CH2, and then CHO. Is this clear? Meaning that this carbon is attached to hydrogen and then double bond to oxygen. You get what I'm saying? But this one will be represented as CH3, CO, CH3, and that's that basically. Is this clear?
Yes.
Okay, very good. So that's that basically. So once you are talking about your ketone is characterized by non-terminal, as you can see in A. The carbonyl group is not in the last carbon. However, in the case of aldehydes are characterized by your terminal carbonyl, basically, and that's that. So let's go to the other ones to save time. Now, moving ahead, the next thing is the carboxylic acid. Once you see this carboxyl group, not carbonyl, carboxyl, in some cases they call it carboxylic group, in some cases they call it carboxyl group. That is C double bond O then attached to OH. So when your carbonyl is attached to hydroxyl, Are you seeing what I'm saying here? Carboxylic is when carbonyl is attached to hydroxyl group. When you combine the two of them, what you get is carboxylic. Do you understand?
Yeah.
Okay, good. So the implication is that if you see a compound, and in that compound you have something like CH3, COOH, what are you likely suspecting? Is this an alkanol, an aldehyde, a ketone? What are you suspecting is this?
Alkanoid.
Exactly. Why is an alkanoic? Is because it has this COOH. Now, there are different ways carboxylic group can be represented. Let me just take everything out. So, different ways carboxylic group, you can either see it structurally as they could just write it in the condensed form like this. If they don't write it like this, they could write it like this: double bond, then OH. In some cases, some people write it like CO2H. So the point is, once you have a situation where you see COOH, that is a carbonyl group attached to hydroxy, or carboxylic group as it is, any of these forms are the different ways they write it. This is basically what represents the carboxylic group. And anybody that has this thing is an organic acid. Understood?
Yeah.
Good. So that's why if you happen to see something like this, you have this, then you now have COOH, and then you have the second. Now you already know somehow, it's an obvious thing. This is benzene ring, right?
Yes,
But-
benzoic.
Exactly. So this is going to be the benzoic acid. Why? Because it has a carboxylic group. I hope this thing I'm saying is making sense to you.
Yeah.
Okay, so moving ahead, we'll go on to the next one. The
Okay,
ne-
question.
Go ahead. Yes, what's your question?
So that means these alkenes and the rest of them, they're under organic chemistry, but they're not organic acid.
Yes, they're not organic acids, they're just organic compounds. The only compound that is an organic acid is a compound that has the carboxylic group. Do you understand?
Yeah.
And that's why even amino acid you get, your amino acid, there's so many forms of amino acid. You get what I'm saying? So any one of the amino acids that you're talking about must possess the carboxylic group. Are you getting what I'm saying?
Yeah.
So that's that basically. Glycine, and the rest of them. All of them must possess this carboxylic group for it to be referred to as an acid. Now the only difference in amino acid is this. If you are considering something like, okay, let's look at an amino acid like glycine. Glycine is one of the most basic amino acid. It contains 2 carbon atoms. You get. So one of the carbon atoms will have your COOH, while the other carbon atom will have your amine. So this is your glycine. So notice, it's an amino acid. How do you know that it's an acid? First, amino because it has the amine group, and then acid because it has the carboxylic group. Is this clear?
Yeah.
Okay, so that's that basically. Okay, with this said, we can move ahead to. You can see this. You can see my board, right?
Yes.
Okay, good. So let's continue. Now, the next one is the ester. Now, an ester is a product of a reaction between an alkanol and an alkanoic acid. And the process is known as esterification. So I'm going to take this all out. So if you have a reaction between an alkanol, you know, what's the functional group of an alkanol?
Hydroxyl group.
Exactly. So once you have an alkanol, it could be CH3OH reacting with an alkanoic acid, CH3COOH. Now you are noticing that this is alkanoic because of the COOH. So what happens here in esterification is that this particular alkyl group, let me try to use different colors so that it would make it more understandable. Let's try to fill this thing with. Okay, okay, so notice this side. This particular guy now is going to leave here and then replace hydrogen here, while hydrogen will leave here and combine with OH to form water. So see what is going to happen. This side will come here. So if we are putting this compound, the new compound that will be formed would have CH3COO, but instead of hydrogen, I said that it is going to be replaced by this part of alkanol. Are you with me?
Yes.
Good. So this is going to have CH3. So plus, then you have that the water will be formed, because when hydrogen and OH combine, what you have formed is H2O. Is this clear? Okay, you perform this reaction for me. I have CH3 and I have let's change it a little bit. So let's say I have ethanol C2H5OH, and then I have added to your methanoic acid. Okay, so tell me, what's the product of this reaction? Remember, all you need to do is the acid, you remove the hydrogen attached to the hydroxyl group of the carboxylic group and remove it, and then replace it with the alkyl group, and you have your answer. Okay, can you give me what you have? What do you have?
HCOO.
Exactly.
C2H5.
HCOO. Then you now take this C2H5 and replace the hydrogen. So it's going to be C2H5 plus, then you have water, H2. Is it clear?
Name the compound.
Okay, so to name this compound is quite simple. In naming esters, you name this alkyl part. This is referred to as the alkyl, while this is referred to as the alkanoate. You get? Now, the alkyl group is named first, while this part is named second. So if we are to name this group now, we'll start with this alkyl. How many carbon atoms?
Ethyl metanoate.
Thank you. So you will notice that this is going to be ethyl because it has 2 carbon atoms, and because the alkanoate has 1, it will be ethyl metanoate. We are going to do this thing ahead here. Here would be methyl, then here is 2 carbon atoms to the alkanoate side, so this is methyl ethanoate. And you know you won't say ethanoate methyl, so you have to rearrange it. Methyl ethanoate. So remember, in naming your esters, this particular alkyl is named before or mentioned before you talk about the alkanoates, because the alkanoate is like the major group here. It's like the parent group. We will see that also in order of priority. Can I continue? Is this clear?
Yes, can continue.
Okay, very good. Now, we go to the next one,
Yes.
which is your amines. Now, the amine group is simply a derivative, an organic compound that is derived from ammonia. So I'm going to take this out and explain. Okay, so if I have ammonia, ammonia is NH3, right? Right? This is ammonia, Abi, student.
Yeah.
Good. Now,
Yeah.
if I want to form ammonia, amine, this is ammonia. But ammonia is what is used to form amines. How? When an alkyl group replaces the hydrogen in ammonia, it forms an amine. So which means if I have this particular ammonia and then I replace one of the hydrogens with an alkyl group, this one now is called primary amine. Are you following me now? Did you get
Yes.
this? Good. So if you replace only one hydrogen with alkyl group, it's primary amine. Okay. Now after the primary amine is formed, you now replace one more. If you replace 2 of the hydrogens in ammonia by 2 alkyl groups, what you now have here is called secondary amine. Is this clear?
Yes.
Okay, then which means that if, for instance, I now need to replace 3 of the hydrogens in ammonia with alkyl groups, R, let's call prime, same thing or different things. What is this one now going to refer to as now?
Tertiary.
Tertiary amine. So that's that basically. So you find out that the whole groups of amines that are formed, or different classes of amines, is simply derived from ammonia. If you replace 1 hydrogen, you have primary. If you replace 2, you have secondary. If you replace 3, you have tertiary. Are you writing?
Yeah.
Okay, so should I give you time to write?
No.
Oh, you're done writing? Okay, good. So let's continue.
No.
Eh? No, as in I should give you time, or no, as in you're not done writing?
I'm not done writing.
Oh, you're right now. If you finish writing, you tell me what you wrote to, so I'll be sure that you wrote something nice.
Uncle, what is the name of the functional group of esters?
Esters. Oh yes, I forgot to mention that. The carboxylate group. Carboxylate group is the
What
functional
about
group for
amine?
esters. Then amines are amine group. Amines are amine group or amine group. So the thing about the amine group is, as I said, nitrogen is the functional group. But then it's not just nitrogen. If you can look at this, in the case of amines, how do you represent its functional group properly? If you have nitrogen with single bonds attached to alkyl group, that is basically the functional group of amines. Now, if it is only one alkyl, primary amine. If you now have two alkyls, secondary amine. But in a situation where you now have three alkyl groups, which could be the same or different, this is now tertiary amine. Is it clear?
Yeah, so the functional group is alkyl and hydrogen.
No. The functional group for amine is called the amine group. The amine group is nitrogen with single bonds. Are you getting what I'm saying? So if that single bond is now attached to one alkyl by a single bond, it is primary. It is attached to two, secondary, three, tertiary. So just note that it is the amine group. The amine group is nitrogen with single bonds. See it like that. Why I'm saying this way is you could just say that the amine group is NH2, but this NH2 only applies to primary. It can be NH. The point is this nitrogen has to have single bond, because if you have nitrogen and it has triple bond, it is a nitrile instead of an amine. Are you still with me?
Yes.
If you have nitrogen and it has double bond to carbon, it is now an imine. It is now what? An imine. So all them hydrazines, your oximes and the rest of them, those guys are imines. So basically that. I meant hydrazone anyway, not hydrazine. Hydrazones, your oximes, your semi-carbazones, your carbazones, those guys are imines. Why? They have nitrogen but double bond. So nitrogen single bonds is amine, nitrogen triple bond is nitrile, and nitrogen double bond to carbon. So you could put that down. Nitrogen single bond to carbon, amines. Nitrogen triple bond to carbon, nitriles. Nitrogen double bond to carbon, imines. You can put that down. Very important. So this is nitrile, this is imine, and this is amine. We'll get to see them as we go further. I'm just trying to highlight the popular ones so that we'll be able to discuss naming of those guys. Now we're going to discuss naming cyclic compounds separately though. You get? Your cyclic organic compounds. We'll discuss them separately. Aromatics too. We'll discuss them. Okay, good. Now the next functional group that is of emphasis here is what we refer to as the amide. Now, both the amide and the amines are like sister groups because they both have nitrogen with single bonds. But the difference between an amine and an amide is this. An amide group is formed by a combination of carbonyl and amine. Are you following? If I combine a carbonyl group, what is a carbonyl group? Do you remember? What is a carbonyl group? Do you remember? Yes? Student, are you still in class? Have you left? Student, can you still hear me? Oh. Student?
Yeah.
What happened? Did you leave?
No, you stopped talking.
No, I did not stop talking. Probably your service was bad, but let's continue. So back to this board. I said the amide group is a combination of carbonyl and amine. So what's the carbonyl group? Do you remember? What's the structure? Combination of what and what is carbonyl?
C double bond oxygen.
Exactly. So this is carbonyl. If you now attach it to amine, I told you amine is just nitrogen that has single bonds, all three. Are you getting what I'm saying? Are you following?
No.
Yes, now didn't I mention it earlier? That
What
when
are you talking about?
I said amide group is a combination
amide.
of carbonyl and amine. Carbonyl is C double bond O, and amine is when nitrogen is attached by single bonds to a particular organic part. Are you guessing what I'm saying?
Yes.
Okay, good. So with this now, the implication is that if I join these two, what I will get is amide. So your amide group will now be equals nitrogen attached to C double bond O. Then you could have any other thing here. Now also you could have any other thing here. Now if only one carbon is attached to nitrogen, this is going to be referred to, that's if you have the carbon of the carbonyl attached to nitrogen, this one is primary amide. Are you following? If this is hydrogen, so this is primary amide. Are you following?
Yeah.
If I now have another one where nitrogen is attached to alkyl group, you know this, like alkyl group has carbon, the carbon of the alkyl group is what is attaching, so it's now attached to two carbon atoms. What will it now become? Secondary amide. Should I continue?
Yes.
Then in a scenario where you have nitrogen attached to carbonyl group, which is one carbon here, then another alkyl group, which is two carbons, another alkyl group, which is three carbons, it is going to be referred to as tertiary amide. So this is how to classify your amides. We will discuss how to name amides like in a different section or a different study, sure? You get, but just put this, take note of these things. Are you writing?
Yeah.
Okay, be fast. When you're done, you tell me. Anybody we won't fight? Are you done?
Uncle, what is the functional group of amide?
The amide group is the functional group. Do you understand? The amide group is the functional group for amides. So that's that basically. So can I continue?
Yeah.
Okay. So with that said, moving ahead, yeah. So, having said that, these are the major functional groups we are going to be discussing. There are so many more. If you notice, I mentioned some that are not in this table. The imines, the nitrile, we will come across them as we go further. But for now, let's take note of these ones because these are the major ones. Now, having said this and understood